All right, so we get to there, and we go. So look at example 2 on that section. It's got the integral of 1 over 4x minus 1. And that is your dx situation here. So, again, this is in the form of 1 over something to the first power, right? So that's what I'm going to look at as far as my u substitution is concerned. What will I let u equal to in this case? Yeah. So u is going to be 4x minus 1. So du is going to be 4 dx, right? What's wrong? So yeah, we have du over 4 equals dx. So this becomes the integral of 1/4 of 1 over u du. Are we okay with this?
So we could.
Ethan,
we could
you
write
looking?
du over du.
Do you follow what I did? Okay. What were you saying?
We can write du over u for that.
Yeah, you could write du. Yeah. You could do that, and you'd be fine. So this is going to be 1/4 of the natural log of the absolute value of 4x minus 1 plus a constant, which is 1/4 of the natural log of, oh, I've already got that, never mind. I went ahead and substituted in there. Okay, so that becomes the solution to that problem. Is there a question about that? Now again, this is all in the choosing techniques of integration. Another scenario that you could run into that would require something a little bit different is if you had something along the lines of x squared or x squared plus 3x plus 1 over 2x. Bless you. Now again, it's in the form of a fraction, but in this case right here, I don't have it set up immediately in this form of 1 over x dx. Now, so the next thing I might be thinking about doing is, hey, let's do a u substitution right here. So if you go to a u substitution here, u equals to x squared plus 3x plus 1. Don't write this down because this is incorrect. Du would equal to what? 2x plus 3 dx, right? Well, what runs into being our problem here? We've got this 2x plus 3 in here, right?
Yeah.
Now I've got a 2x here, but even if this was just 2x, it still wouldn't work because you don't have a 2x times dx, it's a 1 over 2x times dx. Where right here, it's 2x plus 3 times dx. So we've got a problem here. So that does not work for us as well. So we've looked at, even though this derivative, or this value in the denominator is to the first power, the natural log does not work here immediately. And then we have let's try u substitution, and we see that u substitution also did not work here. So, several different ways we could start it out, but you see the hiccup that you hit each time. So again, we got to try something different. Does anybody have something that they say, hey, let's try this and see if it works? Here. And we've done one like this before. It's just been a while. Okay, I must not have done a great job of teaching that day. What are you saying?
Like, if you write it, oh no, wait, okay. If you write it out as like x squared over 2x plus 3x over 2x plus 4 over 2x.
All right, so let's turn it into three different integrals here. Let's make it x squared over 2x dx plus 3x over 2x dx plus 1 over 2x dx. The integrals of each one of those. And what advantage does that give us? And you can write this down because this one is correct. What is our advantage there? You could do each term. What would you want to do before you did that, though? Not really use substitution. Someone say simplify.
Simplify.
We simplify them. Okay. So we would simplify it. So what does x squared over 2x simplify to become?
X over 2.
X over 2? Okay. And what does 3x over 2x simplify to become?
3 over 2.
3 over 2. And then it's 1/2 of 1 over x dx. Is everybody okay with this? All right. So, what is the integral of x dx? Again, x is the same thing as x to the first power, so with the power rule, say that again. X squared over 2, okay. So I've got 1/2 of x squared over 2. I'm not going to put the plus c in here yet. I'm going to wait until the end to put it in there. All right, remember, 3/2 dx is the same thing as 3/2 times x to the 0 dx. Or think about it like this. What would have a slope of 3/2?
3/2 x.
3/2 x, yeah. So this is going to be plus 3/2 x. Or if you want to think about that as 3/2 x to the first over 1. That works as well. That's where I was going with that x to the 0 power. And then you have 1/2 of 1 over x. Well, here's where we hit into that 1 over x, right? So how did we say we were going to deal with that 1 over x there? Natural log. So it's plus 1/2 of the natural log of the absolute value of x plus our constant there. And of course, we could simplify this by making this x squared over 4 and so forth to get the end result there if we wanted to simplify it out all the way. So, again, we've looked at fractions. One thing we've looked at with fractions is, hey, I've got a fraction here. Let me try just going straight at the natural log with something to the first power. No, this was not, I'm sorry, I pointed to the wrong problem. I erased that problem from earlier. Oh, it's this one here, never mind. This is already to the first power, so it just became that natural log. This was one where, again, we did a u substitution to come up with the correct answer. This one right here was, we just had to split it up into multiple. Now, the only reason this splits up into multiple correctly is because it's over a monomial. If this is over anything like 2x plus 1, then we're looking at something different here. If y'all, or soccer, if y'all need to head on. Again, this is getting recorded. So y'all can watch it. Yeah, watch it tonight as y'all are driving up there or something. I don't know. All right, that was lame, but anyway. All right, now, can we keep going from here? Okay. Now, there are other times when fractions come into play, and I'm going to put this on a different video.